Provisional accommodation in modular houses for people who lost their homes during disasters is more superior when made from wood than from steel. Introduction. Responding to emergencies takes up a lot of time in the temporary shelter management fields. Following any incident, getting the impacted population back to normal is the top priority. Restoring the afflicted individuals who lost their houses and removing the event's aftermath are the initial steps towards this return to normalcy. The article presents a brief statistic which shows the number of people who lost their homes due to natural disasters and wars worldwide in the past 5 years. Considering all the disasters that are happening in the world and the improvement of industrialization of construction, in this article, two different types of modular houses are presented along with separate specifications. When designing and analyzing these two types of modular houses, the main factors were manufacturing cost and project feasibility. The advantages of these places of residence in question are quick manufacturing, transportation, and construction. A complete house can be assembled on one truck for transport, and after delivery, no special foundations need to be installed. The same truck is sufficient for unloading and placing the house in its designated place. In this project, two types of modular houses are analyzed: steel and wood. They were chosen because there are a lot of differences between these two systems, which have their own advantages and disadvantages. The metal house was designed in such a way that it could be covered by sandwich panels, which are increasingly used in structural applications due to their high strength, stiffness to weight ratio, corrosion resistance, and low thermal and sound conductivity. To place the sandwich panels in the house, a metal supporting frame had to be designed. The wooden house was designed in such a way that the entire supporting frame is made of wood. Wood in construction is a sustainable and renewable material. When properly protected, has good mechanical properties. The main target of this project is to analyze two diverse constructive places of residence which could bring normality of daily life for people who lost their homes due to natural disasters or wars. The literature review was conducted by searching for articles, publications, and studies on platforms such as Google Scholar, Science Direct, Web of Science, and related platforms. Methodology. For this research, main objectives to be compared are thermal insulation for each framework, material quantity of each framework, cost of each framework materials, carbon dioxide emissions of each framework, time consumption for each framework, the difference of structure in terms of lifespan. Wooden frame. For the structural part, timber framework consists of 90-45 cross-section struts reinforced by an additional 120-45 cross-section struts. These struts have a step of 60 centimeters. The base of the structure consists of 245 timber beams. Openings are additionally reinforced by 90-45 cross-section struts and beams. The roof of the structure consists of 245 cross-section rafts. Metal frame. The base perimeter consists of a square hollow section profile 180 on 5, to which the UPN 100 profiles are connected to create a rigid base for the structure. To form the load-bearing frames, square hollow section 185 profiles are used in the corners of the house. Openings are framed by U profiles. The roof consists of load-bearing square hollow section 185 beams, to which the UPN 100 profiles are connected to create a rigid roof. Material quantity. The required amount of every material that differs. Wood 1,337 kilograms, steel 2,193 kilograms, polyurethane 57 square meters, mineral wool 26 cubic meters. The exact list of material name, technical characteristics, and quantity is given in the supplementary materials section. Cost of materials. When calculating the production price of modular houses, the following works were not evaluated: interior decoration, internal partitions, foundations, windows, doors, flooring, and engineering systems. Three different comparisons of prices were made: overall production cost, timber and steel structural material cost, roof and exterior walls cost. Carbon dioxide emissions. The production and construction stage of steel framework modular house generates approximately 354 kilograms CO2 equivalent to square meter, while timber generates 42 kilograms CO2 equivalent to square meter. It is important to bear in mind that timber also generates 119 kilograms CO2 equivalent to square meter biogenic carbon, which is beneficial for its ability to absorb and reduce atmospheric CO2. Time consumption. Using the MS project software based on labor cost, a calendar schedule for modular house production work was prepared. The calendar schedule indicates the work to be performed and the duration of its completion. For wooden modular house, it takes 13 days for the house construction, and for metal modular house, 7 days. Lifespan. Water is the main cause of decay, and in fact, the most relevant performance flaws are strictly related to water absorption. This graph indicates a significant difference in water absorption between mineral wool, which is used in timber prefab house, and polyurethane, which is used in steel prefab house. The biggest gap occurs in the 24-hour mark, where we see that mineral wool absorbs 2 to 3 times more water than polyurethane. Conclusion. Results obtained in the final. The wooden modular house is 30% less expensive. Timber framework is 132% more ecological. Steel framework with sandwich panels is 53% less time consuming. Polyurethane performs better than mineral wool by 26%. Timber framework modular house has advantages in CO2 emission and cost criteria when comparing only structural framework, thermal insulation excluded. Steel framing modular house has advantages in terms of time consumption of assembly and thermal insulation cost and lifespan. The results did not lead to one specific solution. Thus, the recommendation is to create a structure that contains timber framework and sandwich thermal insulation. This modular system has the advantages of both of the options analyzed. It is less expensive and time consuming, as well as having ecological benefits.